Hello, this is our last question on tutorial sheet 4 for Engineering Mechanics 1 Statics ME4111 at the University of Limerick. So we're on question 7. And we've got this kind of complicated slab that has a number of forces acting on it. We're given some dimensions. It's a bit of a mess with the dimensions. And we're given these 1, 2, 3, 4, 5 forces that are acting on it. So we're told what the magnitude of FA and FB are. So they're given in kilonewtons, which is in keeping with the other forces that are there. And we're asked to determine the magnitude of the resultant force and specify the location of its point of application in terms of X and Y on the slab. Okay, so our coordinate system is coming down here to the corner. So it starts there. And we're asked for the X and Y coordinates of the resultant force. Okay, so we want to find out where is this resultant force such that the moments will all equal 0. In essence, what we're asked to determine the force coupled system such that all the moments will be equal to 0, and where is that location? So we're given our answer here to help us work through it. Right, so our solution. Now, again, this looks a bit complicated, but if you're comfortable with this concept of the force coupled system and equivalent systems, it's actually quite straightforward. So what we're doing is we're going to do 2 steps. The first thing I'm going to do is I'm going to create an equivalent force coupled system at some location. So I'm going to pick somewhere where I'm going to take and make a force coupled system. I'm actually going to pick the origin here, 0, 0. And that's the most sensible point to pick, but I could choose any point whatsoever around this. You know, it doesn't matter where, somewhere inside there if I wanted, it doesn't matter. But some location where there is an equivalent force coupled system. And I evaluate what that is at that location. So I've chosen the origin, and that's what I'm going to do. Once I have that done, what I'm going to do then is I'm going to figure out, well, where does that resultant force need to be located so that the moment is cancelled out. And so that's the nub of the approach. So the first step is to pick a location, which I've chosen as the origin. And I'm going to determine the equivalent force coupled system at that location. So again, I'm following my standard procedure. I've got my translational effects here and my rotational effects here. Okay, so translational effects, again, all the forces are in the negative z direction. So sum of the forces up, I get minus 215 k hat kilonewtons for the resultant force. So that's the magnitude of the resultant force. The second part then, excuse me, is to work out what the moment is about point O due to each of these forces. Okay, so I take moments due to each of those. So again, I got my magnitude, my distance, and then based on the direction, I'm assigning a plus or a minus. So this one will be in the the clockwise direction. So I get a negative moment. Now what I'm doing is I'm not using the vector cross product because again, as in the previous example, all the forces are aligned in a negative z direction. Therefore, they only have a rotation effect about the x-axis and the y-axis, and they have no rotation effect about the z-axis. So in doing that, I'm looking in the y-axis, I hat, and you'll see that I'm taking at the start, I'll just clear that and change what color. I'm just taking the I hat terms here, what I started doing. So I have 1, 2, 3, 4, 5 forces done there. And then I swap on to the J hat terms. And I do those. Okay, so I'm quite systematic about how I'm going about doing it. And you should be quite comfortable about taking moments at this stage about the different axes. So again, it's the magnitude, distance, then look at the rotation direction about the axis and assign a plus or minus based on that. Okay, do not assign a plus or minus because the force is in the minus direction. So when I do that, I get my answer here as minus 791.25 I hat plus 761.25 J hat kilonewton meters. Okay, so in summary, what I have is that at the point 0, 0, this is my equivalent force coupled system. Now what I want to do is I want to work out where this is located so that I take out these moments, that the sum of the moments equals 0. So that's my next step. So I'm going to do this again in relation to the y-axis and the x-axis. So I'm going to start with the x-axis. And again, note that in the x-axis, if I look in from the x-axis, I only see separations in the y-z plane. Okay, so the distances aren't going to be in terms of y. Okay, so y times 215, so 215 here is my magnitude of my force, has to be equal to 791.25, okay, which is the moment about the y-axis. Okay, so I'm just taking the magnitude of that, and I get a distance of 3.68 meters. Now, I don't know, is it 3.68 meters this way, or is it this way? Okay, so what I'm doing is I want this to be a negative moment, which means it's got to be giving a clockwise rotation about the x-axis. And if I have a force acting in the negative z direction, because the resultant is acting in that direction, it has to be located out here to give me a clockwise rotation. So that means it is plus 3.68 meters. Similarly, for the x direction here, I'm looking in from the y-axis. Okay, so I'm only getting distances then that have x in them. So x times 215, again, that's magnitude of my force, is equal to 761.25, which is the value here that I have for my y-axis rotation. So here I get 3.54 meters. And again, I don't know, is it 3.454 meters out this way, or is it back that way? So what I'm going to do is I know my rotation about the y-axis is positive. So therefore, to get a positive rotation, it must be anti-clockwise. So therefore, it's got to be, if the force is acting downwards, it's got to be out this direction. So on the plus side of it. So it's plus 3.54 meters. Okay, so my answer then is the resultant force is minus 215 k hat kilonewtons. I forgot my units on that. And it is located at 3.54 in x and 3.68 in y relative to the origin at that location. Okay, that concludes tutorial G4. Again, tutorial G4 gave quite a lot of questions on force-coupled systems and increased the level of difficulty. So hopefully you can see how useful this approach is. It gives us a lot of flexibility and allows us to understand the effective forces acting in a particular location. So if we're focused on a particular joint, if we're forming a connection here, for example, or we're looking at this system, we can figure out, well, where's the resultant force of all those effectively located. So it's very, very powerful and very, very useful, and it's something you should become very, very comfortable with. Okay, I hope you found those tutorial sheet 4 solutions useful, and we'll move on to tutorial sheet 5 next. Thank you. Bye-bye.